Alright, so topic 2 is graphing these exponential functions. So our central question, how can you tell if an exponential function is growth or decay? And then how can you use the table, the graph, or the equation to find the y-intercept and the growth or decay factor for the function? Okay, so there's two kinds of graphs that we're going to be looking at. Both are exponential functions, just one's a growth and one's a decay. So over here, I'm going to kind of sketch these graphs out. So this is the x-axis and the y-axis. We only need the top half. We only need quadrants 1 and 2 because the parent function stays above the x-axis. Okay, so what is an exponential function? A function of the form y equals a times b to the x, where a can't be 0, because if a is 0, then the whole thing's 0. And b has to be a positive number. It can't be negative because exponential functions aren't going to look like this if it's a negative number. Okay, we are going to have asymptotes here. So an asymptote is the line that the graph approaches more and more closely. So it's going to get closer and closer to it, but it's not actually going to touch it. Okay, so we're going to have two functions here. We're going to have a growth number. It's going to be a growth, which means it starts close to the x-axis. That's my asymptote. And then it goes up. So this one's growth. And we're also going to have a decay graph, which is starts high and then decreases here. So again, getting closer and closer to the x-axis. So the x-axis in this case is the asymptote. So right here, the y equals 0 line, which is the x-axis, is the asymptote for this one, but it changes if you shift it. Okay, and then again, the growth factor is whatever this b is in the equation. So the b value is going to tell you if it's growth or decay. So b is called your base. So whatever the base is of the function, that tells you whether it's growth or decay. There's always going to be a base. There doesn't always have to be an a number there. There always has to be a base though. Okay, so again, transformations. Looking at the parent function. So here goes our general form, right here, our transformation form. So first you look at the base, which is the one right beneath the exponent. That's going to tell you if it's growth or decay. If that number is greater than 1, it's growth. The graph is an exponential growth function. If it's a fraction between 0 and 1, then it's decay. That number cannot be negative. So never will this thing be negative for exponential functions. If it's negative, it's a different kind of graph. Okay, that's the only new one. These are all the same. So the k will be a number added to the outside, and this shifts it up or down. So for a positive k greater than 0, it's going to shift up k units. For a negative number less than 0, it's going to shift down k units. And this number out here is going to give us our horizontal asymptote. Okay, so whatever this number is, that's where it's going to flatline. The graph is going to flat out, or get flat and approach that line. Okay, the h value, which is part of the exponent up here, shifts it left or right just like it has always. So if it's an x minus h, it's going to shift it right, h units. If it's a plus h, it's going to shift it left h units. So again, that hasn't changed. It's still the opposite. There's no parentheses there, but if we had to write it out, we would have parentheses. We would need parentheses up there on the exponent. Okay, and then an a is a number multiplied to the front of the graph. So it's being multiplied to the base. If a is greater than 1, so this is like if a is 2 or 3, then it vertically stretches. And it's all vertically, so I'm not going to write vertically every time. If it's a fraction between 0 and 1, like a half, then this compresses, vertically compresses by a half. If it's negative, it's going to make it reflect over the x-axis. So a couple of things with the reflections here. If it ends up reflecting over the x-axis, that's actually going to change this part. Because it's going to be pointing down, then it's going to switch growth to decay and decay to growth, depending on what it is. There's one more thing I want to mention here. In front of the x, if this number is negative, so if it's a negative x in front, this is going to make it reflect over the y. Which again is going to change the growth or decay part. So if you're reflecting it, and we'll see that when we actually graph it, if we have any kind of negatives in the front or up there with the x, it's going to make this thing change to the opposite. Okay, and we'll see that down here at the bottom. Okay, so looking at these examples, we are stating the transformations, up, down, left, right, stretch, compress, reflect, and we're giving saying if it's growth or decay, and giving the asymptote. Okay, so first, the growth. I would go through all of them and identify the growth or decay first. So this is going to be your b value, the one right beneath the exponent. So here for the a, this is the base. 3 is the base. So this is telling us that it's a growth. If we look here, this one, it's a fraction, so it's right beneath the exponent. So just looking at this is decay. I'm going to come back to that one though. I'm going to come back to all of them. But this is what I mean by going through all of them and saying if it's growth or decay. Over here, exponent, so the base is this, which is growth. Here's the base again. So 5/3, that's actually more than 1. It's just because it's a fraction doesn't automatically make it decay. Since it's more than 1, this is growth as well. And then here, the e is right beneath the exponent. Not the negative itself, just the e. Because remember, the base cannot be negative. This number is 2.718, blah, 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 which is more than 1. So this would be a growth. We'll get to e later in this unit, but you're going to see some of them with e, so I wanted to make sure I talk about it here. It is a number like pi, but we'll come back to that. Okay, so those are all the growth or decay just by looking at the base. So now we're going to go through and state the transformations and the asymptote. So remember, the asymptote is always given by the k. So here, if we just say all of them, the half in the front is going to compress vertically by half. The 6, that's part of the exponent, is going to make it shift right, because it's the opposite. And the 1 out here shifts it up 1. Okay, so those are the 4 transformations. The horizontal asymptote is given by the k number. So we say the horizontal asymptote is the line y equals 1. That's the line where it's going to flatline and get closer and closer to. Alright, so looking at the calculator, this equation would still look like the shape that we saw at the top, the J shape. So it's growth because it's flattening it out. It starts with flat and it goes up. It's flatlined at 1 because that's the horizontal asymptote. And it's being shifted right and up a little bit. So you really can't see the compression in the graph, but you know it's being compressed because the number's there. But this is what I mean by horizontal asymptote. It flatlines at 1 here on the Y. And then it goes up from there. Okay, so looking at this one, the second one here. So if we start with the K, the -4 is going to make it go down 4, which tells us our horizontal asymptote is Y equals -4. Why is it doing that? Okay, and then the 1 as part of the exponent is going to make it go left 1. The 2 that's in front of the fraction, so this 2 right here, just the 2 by itself, makes it vertically stretch by 2. So you don't actually multiply these two numbers together to get the base. Order of operations say we have to do exponents before we multiply. So you can't just multiply them together. And then notice here there's a negative in the front, which makes it reflect over the x-axis. Alright, so I do want to show you this one on the graph. Because it's reflecting over the x-axis, that's going to end up changing this number, or this base, to the opposite. It's going to make it a growth. And I'm going to show you why with the graph. Alright, so for this graph, if we look over here, because it's a negative, that's what the graph looks like, it actually starts low and goes up, getting closer and closer to that asymptote. The original graph was decay. If I can move this thing. So the original graph did start high and then get flat this way, but because so it was decay, but because we reflected it, now it's starting low and going up. So that's why it changes the original base to the opposite. Okay, so you have to be careful with those negatives. Negative just makes it do the opposite of what the original base was. Okay, so we're going to see a negative over here, so that one's going to change it as well. But finishing off these two, looking at C, the +3 makes it go up 3, which tells us that our horizontal asymptote is at 3. And the +5 up here makes it go left 5. Okay, there is no A, there is no number in the front, so we don't have to worry about stretch, compress, or reflecting. The 4 is the base. That doesn't do anything as far as transformations. That just tells you the growth or decay. Right, and then for D, we only have a -5 out here. So this one makes it go down 5, which tells us that our horizontal asymptote is at -5. So Y equals -5. Again, there is no H because there's no number with the X. There is no A because there's no number in front of the base. And this is a growth because it was more than 1. Okay, so for this one, remember the negative in the front makes the graph reflect over the X. Which in turn changes this to a decay. So again, be careful with those negatives. Now, the -2 here is part of the exponent. So since the -2 is part of the exponent, this is going to make it shift left and right, not up and down. So this is an H value. So this number makes it go right 2, not down 2. This one has no k, but we do need a k out here for the horizontal asymptote because it's still going to have an asymptote. So what would the horizontal asymptote be if there's not a k? Well, it's like it's plus 0, so the horizontal asymptote would be at 0. So again, if we looked at this graph, let me kind of erase this over here. Alright, so again here looking at this graph, it was growth, so the original graph was flatlined here, and it went up. But because we reflected over the x-axis, it's going to go down now. So when it goes down, it's decay. And it flatlines right here at 0. So that's why the horizontal asymptote is 0. So it's always going to have an asymptote, but it might not be, there in the equation. If it's not there, you have to know that it's 0. Okay, so here we're going to graph these using the parent function. So we're going to do the growth parent function first, and then we'll do the decay parent function. So growth, remember, the base can be anything greater than 1. So as long as it's greater than 1, it's going to be a growth. And this is the parent function for all growths with base b. Now to make it simple, I'm going to put b as 2. I'm going to make my base 2. And I'm actually going to extend this a little further for this one. I'm going to do a 3 and a 4 just so we can get a better shape of the graph. But usually we can only get those points. We won't fit these because they're too far off the graph. Okay, so the graph's going to look the same regardless of what your base is, as long as it's more than 1. They're all going to look the same, but we need a base to get some points. Okay, so what does this mean? This means my base is 2 for all these numbers. This is the exponent. So the 4 is the exponent here. The 3 is the exponent. The 2, the 1, the 0, -1, and -2. Okay, well let's start with ones that we know. I know 2 squared is 4. I know 2 cubed is 8. 2 to the 4th is 16. But if I go backwards, 2 to the 1 is itself 2. 2 to the 0, though, if you remember the rule from properties of exponents, anything to the 0 power is always 1. This one is going to give you your y-intercept. Whatever this one is your y-intercept. And it's 1 unless you're stretching or compressing it. If you're stretching or compressing it, it's going to move this point. Otherwise, you're always going to have 0, 1 on the graph. Now, what about negative exponents? If you remember what negative exponents do, they don't make the number negatives. We never have negatives for exponential parent functions. So notice the pattern. 16 to 8, we divide by 2. Divide by 2, divide by 2, divide by 2. So what's 1 divided by 2? Well, it's a half. And if I have a half and I divide it by 2, then I get a fourth. So all negative exponents do is they make them fractions, and then to get the denominator you just square or cube or whatever the number, the base is. So 2 squared is 4, but 4 is going to be in the bottom. 2 to the 1 is 2, but it's going to be in the bottom. Okay, so if we graph this, we can't fit 16, but we can we fit 8? I don't think we can fit 8. So 2, 1, 2, 3, 4. 2 is at 4, 1 is at 2. 0 is at 1. -1 is at a half. And -2 is at a fourth. So for these, for sure, I need 3 points, the y-intercept plus either 2 to the right of it or 1 on each side of it. So you want to make it flatline. So here, the horizontal asymptote is the x-axis, which is y equals 0. So we draw a dashed line for the horizontal asymptote. and we make this start flat, go through the points, and then go up forever. So again, it's a growth because it's increasing from left to right. It's going up. So the domain, it's always going to go to the left forever and to the right forever. So the domain is all real numbers. So here we write in symbols, domain is x in the reals. The range though does change. So it's never going to go past this asymptote. So here we say the range is all the y's that are more than the asymptote, which is 0. Not equal to. It cannot be, it will not touch the asymptote. So it's always going to be greater than, or if it's reflected, it's going to be less than. So y is greater than 0 for this one. So again, the y-intercept you'll have here. That's your main point, and then you go a little bit above and below. Or if this one's too small, then you can get 2 above. Alright, so now we're actually going to graph some functions. We're not going to graph all of them by plugging in. We'll look at the table and then we'll get the points that way. But I do want to show you how to get a few of the points. Alright, so for these right here, I am going to use the calculator to get the tables. However, at the end, I do want to come back and show you how to get it without the tables, because sometimes you need to be able to generate the function by plugging in values, not just by using the calculator. Okay, so here we're graphing 1/8 times 10 to the x. So again, just stating the transformations and the growth or decay. I mean, growth or decay is not a transformation, but you should always think about what it is, which one it is. So here the 10 is your base. So here the base is 10. So this tells us it's going to be a growth. And then we have a 1/8 in the front, which means it's going to compress by that. So it's going to make it flatten out a little, not very much. But it's still going to have that J looking shape. Okay, so those are the transformations. I do want to move it up, that way we have the blanks at the bottom. So this was a typo. This should be y equals 1/8 times 10 to the x. That's what we're graphing. Okay, so let's come over here and graph it in our calculator. So in a new graph, we're going to do f of x equals fraction 1/8, and then come over here times 10 to the x power. And we enter that. So we know the graph is going to be a growth, so it's going to be increasing, but we want specific points here. So if we go Control T, we'll be able to get the table. So going to -2. Whoa, that's a small number. So here, 0.00125. Not going to fit that one. 0.0125. Not going to fit that one. 0.125 maybe. 1.25. 12.5. And then coming down a little bit. After 12.5, it jumps way up to 125. So definitely not going to fit that one. So again, you're not going to fit the whole table. As long as you can fit 3 points, that's fine. So here are the 3 points that we can fit. This one, 1 is at 1 1/4. 2 is at 12 1/2. And then 0 is not even 1/4 of the way. So it's hard for me to do 0. So just know that when you graph these, I mean, some of them are going to be really big, some of them are going to be really small. But make sure when you connect the dots, so here's the steep part, if I can make it go up, make sure you do make it flatline. So where is it going to flatline? Well, this thing has no k, so it's like a +0 out here, which means the asymptote is going to be the x-axis, which is the 0 here. So always, always, always graph your asymptote with the dashed line, and then you're going to make your graph flatten out and get closer to it. Okay, so again, it starts flat and it goes up because it's growth. So then this number is also the range. Y is, since it's up above it, it says is greater than 0. We will get to some that are less than when it reflects. And the domain's not going to change. So the domain's always going to be x is all real numbers. Because you can plug in positives, you can plug in negatives, you can plug in fractions, you can plug in anything to the exponent, but you'll always get a positive number as the y value. Okay, so here, again, we're going to use the calculator to get some points, but I'll come back and show you how we get them by hand. Alright, so looking at the next one, we have a negative one here. So I'm not going to do this table right now. We're only going to look at this table right here, and we'll come back to that one later on. But let's describe the transformations first. So first, looking at the base, this is the base right beneath the exponent. Tells us that it's a growth. However, because it's a negative, the negative is going to make it reflect over the x-axis, which is going to change this to decay. So it's going to end up going down. The 2 makes it go to the left 2. And the 12 makes it go up 12. Okay, so in the calculator, we want to clear this one. Oops. I can move it to the middle. So oops, I want to graph. New graph. Okay, so we're going to do negative parentheses 2 to the x plus 2. And this is where you got to be careful. You got to get out of the exponent and do the plus 12. So I'm going to have to adjust my window here. So here, again, it's going to be way up here at 12, but it's going to be going down, which means it's decay. So it was growth. If it wasn't reflected, it would be going up. But because it's being reflected, it's going to end up decaying and pointing downwards. So to see the table, we do Control T. And we want to get numbers that we can kind of fit. So the ones that you want to look at are the ones that are around your h value. So h you want to put in the middle. So the opposite of this would be -2. So that's the one you want in the middle. And then you look a little bit above it and a little bit below it. So -1 and 0, -3 and -4. Okay, otherwise if you don't start with h, then the numbers that are in your table are going to be probably ones that you can't fit. So here, moving up a little bit. So again, if I go too far, these are going to be too close. If I go too far this way, these aren't going to fit on my graph because it only goes to -2. So put -2 in the middle and plot your points. So -4 is at 11.75, -3 is at 11.5, 2 is at 11, -1 is at 10, and 8 is at 0. So 8 is at 0, -1 is at 10, -2 is at 11, -3 is at 11.5, and then 11.75. So I could actually probably fit one more here. So I can fit 1 and 4. But again, you only need 3 points. So we can see how it's starting to decay going downwards. So the other thing you need to graph is your asymptote. So which one of these numbers gives me the asymptote? Remember, it's always the k value. Why did I put 2? It should be 12. So since it went up 12, that's going to be our asymptote at y equals 12. So we want to draw a dashed line, dashed horizontal line at 12. So then it's going to flatline at 12 and go through these points. I could make it connect. And decay because it's pointing downwards. So here again the range has to do with the asymptote. So it's 12. But since it's decaying, since it's going down, it's below that asymptote, we say it's less than 12. So y is less than 12. But the range again is always all real numbers. This is never going to change. These two will always be the same number. You just have to decide if it's a growth or decay, meaning it's, or sorry, not growth or decay, if it's being reflected or not. That's going to change the greater than or less than sign. Okay, and again, we'll come back and do the table to see how to get this by hand, how to get these points by hand. But right now, the important part are the transformations and you being able to say if it's growth or decay.